Hello College Algebra and welcome to Matrices. Okay, you're now on 6.5, which was determinants and Cramer's rule. We've already done determinants. Cramer's rule will be a little bit new, but it's using determinants, so I think you'll like it. Alright, so let's get going. Alright, so we're going to do a second order determinant. We're going to solve for linear variables using Cramer's rule. We'll do a third order determinant and also use Cramer's rule with third order and show you how to evaluate. Now remember, the determinant is when you multiply it. So we took 10 times 5 and we got 50. And 6 times 9 and you got 54. Then you subtracted the 2. So it was 50 minus 54. So this guy's determinant was negative 4. You've already done that. Now we're going to show you how to use this with Cramer's rule. So Cramer's rule, we're solving two equations. So the A are the coefficients and the B's are the coefficients of the Y, C are the solutions. So if I'm finding X, the first column represents X, the second column represents Y. Now let's look at the denominator first. So these are the A's from the X's right here, and the B's from the Y's is where they came from. If I am solving for X, in the numerator, I take out the A values and I replace it with the solutions over here. Y works the same way. The denominator is identical, but now I replace the Y value with the solutions to find it. So let's show you this with some numbers so it makes sense. Okay, so we're going to start with our determinant in the denominator. So that's 5, 3, 4, negative 6, right? 5, 3, 4, negative 6. I am solving for X. So instead of 5, 3 in the X value, I am going to put in 12 and 24. Y stays the same, the 4 and the negative 6. Now you find the determinant of the numerator and the denominator, and you actually divide. So we take 12 times negative 6 minus 24 times 4, which is negative 168. Same in the denominator. 5 times negative 6 minus 3 times 4, negative 42. Divide, and your X value is 4. Now to find the Y value, do the same thing. But now you've already found the denominator's negative 42 and they're identical, so we can write him in. Then we do, now we replace the Y with the solutions and leave the X alone. The 5 and the 3's are the same. 5 times 24 minus 3 times 12, 84 divided by that same denominator is negative 2. So your ordered pair that solves this is 4, negative 2. All right, give yours a shot. Pause and give this a try. So when you were solving for X, your denominator would have been 5, 6, negative 4, negative 5. We don't change anything there. Your numerator, now we're solving for X, so the 5, 6 become the 2 and the 1. The Y stay the same. Okay, now you actually do this multiplication. 2 times negative 5, negative 10, minus 1 times negative 4, negative 4. So we've got a negative 6 in the numerator. 5 times negative 5 is negative 25 minus 6 times negative 4, which is a negative 24, which gives me a negative 1, and your answer is 6. Okay, that was solving for X. Now remember, solving for Y, the denominator doesn't actually change, so we don't have to redo that one. So when we go through here, we are going to have Y equals, so I know my denominator is 1. We'll write it out just so we're okay. 5, 6, negative 4, negative 5. That does not change. I already know that that's equal to negative 1. Now, I am going to replace the Y values this time with the 2 and the 1 and leave the X the same. So now when you multiply, 5 times 1 is 5, minus 6 times 2 is 12. 5 minus 12, negative 7 over negative 1 equals your positive 7. So your point is 6, 7. I hope you did a good job. All right. Third order. Okay, this one's a little harder. There's two ways to do it. I'll show you both, and you can use whichever method you like. One is called expansion by minors, and the other one's diagonals. I actually prefer the second, but some people understand this one better. So what you do is we break this down into 3 smaller matrices. So we take the first one, A. So where A is at, we take out his row and his column, and his new matrix is EFHI. Okay? Now we do the same thing with the next one. So now I'm going to do B. I take out his row and his column, so his is DGFI. DGFI. We switch signs. This goes positive A minus B plus C. So C, now we take out C's rows and columns. So this row and this column, and we're left with DG. This should be EH. So please fix that. All right, we've got that down. So let's do it with numbers. So we're going to start with 1. Now, row and column are gone, so we're left with 5, 8, 6, 9. Row and column gone. Now we go down to the second one. So we're looking at 2. Row and column are, I did it again. I don't know why I don't want to cross off 2. So it's 4, 7, 6, 9, opposite sign, so negative 2. Now you have to go down to the third one. So we're looking at 3, row and column gone, 4, 7, 5, 8. Now we actually just do the determinant. 5 times 9 minus 6 times 8 times 1, negative 2 times 4 times 9 minus 6 times 7 plus 3 times 4 times 8 minus 5 times 8. 5 times 7. Okay, now let's get our math done here. So we take, so this is 45 minus 48, which is going to give us a negative 3. 4 times 9 is 36 minus 42, which is going to give us negative 6. Now we got 4 times 8, which is 32. This one's probably wrong. Minus 35. So this should have been a negative 3. Please fix. Okay, 1 times a negative 3 is negative 3. Plus 12. 3 times a negative 3 is negative 9. Add that up, and we actually got 0 this time. A lot of work for nothing, right? Okay, your turn. Pause and give it a shot. Okay, I hope you did a good job. So you did 4, you crossed these guys out, and you had 3, 4, 6, 3. Then you did minus 2, crossing these out, leaving you with 5, 2, 6, 3. And then you should have done the 3, adding the 3, maybe. So this guy's gone. 5, 2, 3, 4. Now you're doing your math. 3 times 3 is 9 minus 24. 15 minus 12. 20 minus 6. Do all that added up, and you got a negative 24. I hope you did a great job. Okay, that's method 1. That's called expansion by minors. The second method is a diagonal method, and it's very similar to the 2 by 2. You know how we multiply down and subtract multiplying up? We do the exact same thing. This is really hard to read, especially when you're not in front of me. Let's redo this so you can understand. So we got 1, 4, 7, 2, 5, 8, 3, 6, 9. So the step 1 is you rewrite these 2 columns. So 1 and 4, 2 and 5, 3 and 6. So rewrite the columns. 2 columns. Now we actually do the diagonals. So we take 1 times 5 times 9, which is 45, plus, I didn't write this very well, 4 times 8 times 3, which is 96, plus 7 times 2, so 14 times 6, which is 84. All right, now we do the same thing going up. So we take 15 times 7, which is 105, 6 times 8 times 1, 48, and then 9 times 2, 18 times 4, 72. You add those 2 numbers up, that's what I do, add these two numbers up and you subtract them. Let me get my calculator. Okay, when you add the bottom numbers up, you get 225. When you add the top diagonals up, you get 225. You take the bottom one, 225, minus the top one, 225, and your answer is 0 this time. Not a lot of fun. Recognize it? It's the same one we just did. Okay, pause and do yours. All right, I hope you did a good job. All you did here is you rewrote your first two columns. 4 times 3 times 3 is 36. 5 times 4 times 3 is 60. 2 times 2 times 6 is 24. Add those up, you got 120. Now you do the up diagonals. 3 times 3 times 12 or 2 is 18. 6 times 4 times 4 is 96. 3 times 2 times 5 is 30. Add those up and you get 144. Subtract the bottom one minus the upper one, and you got a negative 24. Hope you did a great job. Okay, next, solving linear equations. Okay, what this is we take the first determinant, which are the x, the y, and the z. So this is x, this is y, this is z. Okay, and this is going to be our denominator, what we divide by. This is Kramer's rule again. So we take everybody, we replace no one. Now, if I'm solving for x, I replace the x column with the solutions, which are our d's. If I'm solving for y, I replace the y column with the d's. And when I'm solving for z, I replace the z column with the z's. And then I do the exact same thing, either diagonal or expansion by minors. Okay, here we go. We have 3, negative 2, 1, 2, 3, negative 1, 1, 4, 3. This is my first matrix. I'm just going to do the determinant right now and get this done. So we take 3 times 3 times 3, which is 27, negative 2, negative 1, 1, which is 2, 1 times 2 times 4, which is 8. First diagonals. Now we do subtract the up diagonals. 3, negative 4 times 3 is negative 12. 3 times 2 times negative 2, negative 12. And my denominator is 58. Now we do the x values. Rewrite the first two columns. 6 times 3 times 3, 144. Negative 2, negative 1, 2. 4, 1, negative 9 times 4, 36. So we take the bottom diagonals minus the top diagonals. 2 times 3 times 1 is 6. 1 times negative 4, negative 4 times negative 1, negative 4 times 16, 64. 3 times negative 9 times 2, 54. Subtract those two and we get 116. Now to find the actual value of x, we take 116 divided by 58, your denominator, and that equals 2. So x equals 2. So now we got to find y. Pause and do your 2. Let's see how you do. Okay, I hope you did a good job. So you rewrote your first two columns. You multiplied down, which is negative 8, negative 81, negative 16, positive 4. Add those up, you got a negative 93. Multiplied up, negative 9, negative 6, 96, 81. Negative 93 minus 81 is a negative 174. Divided by 58 is negative 3. So that equals your y value. Now to find z, multiply down, 18, 18, 128, which is 164. Multiply up. I ran out of room, so I moved over here. So 3 times 16 is 48. Multiplied 4, negative 9, and 3 is a negative 108. 2, 2, and negative 2 is negative 8. Negative 68. Subtract those two, which means you're adding. 232 divided by 58 is 4 for z. So your point is 2, negative 3, 4. A lot of work, right? I almost prefer augmented. All right, now we're at higher order derivatives. We have to use expansion by minors. There's no option. Okay, so to do this, we pick the column that has the most zeros in it. So when I look here, this column has the most zeros. So that's the one we're going to use. Now what you do is you take negative 1, it's always negative 1, to the position of the column. So this guy is in row 1, column 3, right? So 1 and 3. So you take the 3 plus the 1 is to the 4th power. That's where that comes from. Times the 3, the number itself, and then you take out his row and his column, and that is your new matrix you're working with. Now we do the same thing with the other one that's not a 0. So this time it's -4. Okay, he is in row 4, column 3. So we take -1 to the 4 plus 3 power, which is 7, so it's going to stay -1, times the -4, take out his row and column to get his new determinant, our matrix. All right, to do this, I used diagonal method. So I rewrote the first 2 columns. I multiplied down like we did before, multiplied up like we did before. Then I subtracted my answers. So this was -8, this was 17. So -8 minus 17 is -25. So this is this guy's answer times -1 to the 4th is +1 times 3, which is just 3. So it's 3 times -5, 25. Same thing over here. But this time I have to take, this is a negative to the 7th, so that's a -1 times -4, so that's a +4. Now I multiply again, multiply down, which is your -3. This guy is 0. This guy is 0. So we got -3 on my down. Now let's multiply up. 0, 4. -3 times -1 is 3 times -2 is -6. So your answer here is -2. So now you're taking -3 minus a -2, which equals -1. So it's 4 times -1, and your solution is -79. Okay, pause and try yours. I know it's a lot of work, but it's not terrible. Pick your column wisely. I actually chose the first column if you want to know how I'm going to do it, but the first or the 4th would have worked. Okay, I hope you did a great job. I took 2 times, take out its rows and columns, and that's -1 to the squared, because this is row 1, column 1. Then it's -1. 4 is in row 1, row 2, column 1, so that's 2 cubed, so he's negative. And then again, take out his row and column. -1 here, this is 4th row, column 1, so that's 5, so that's a -6 also. Now you just did your multiplication with your matrices, and I had 2 -54, and 4 -8, -6 -8, and got -28. I hope you did a great job. All right, homework time, and do a great job. Post questions if you have any.